my dear student, after looking on this figure that explain the displacement of the progressive wave. Now it is a time to go and conclude to produce our observation from the figure there, the past figure. We should say that therefore the displacement y of the particle p at a distance x is given by this one. How can we get the displacement y of the particle p at a distance x, my lovely students? So we get this displacement y of the particle p at a distance x by expressing as the y, the displacement along to the x, t, along to the axis at the point, to the coordinate point x, t, might be equal to a sine bracket wt minus the face angle. Kwa hii ndio formula ambayo tunakuwa tunaitumia kuweza kutafuta yule displacement y of the particle p, my lovely student, kwa kusema kwamba displacement along the coordinate point x, t might be equal to a sine bracket wt minus the face angle. Hii later in express at the face angle, my lovely student. So after there, this will be our equation number 10 for our topic number 8. Kwa hiyo hapa ndio itakuwa equation yetu number 10 for our topic number 8, my lovely students. So also at the point M from O, kwenye point M sasa ambao ni sehemu ambayo ilikuwa ina indicate that the whereby the one oscillation is completed pale. Sasa ile distance tunaita ni one wavelength. Kwa hiyo itakuwa allocate the one wavelength from the equilibrium position pa kwenye point M, ile inatupatia one wavelength as we have been told, my lovely students. So has a phase displacement of 2 pi. Kwa hiyo inakuwa ina contain comprising the phase the phase difference which is called the 2 pi, my lovely students. So that's it. Particle p from O has a phase displacement of this one. Kwa sasa ili tuweze kupata kwenye particle p kutoka kwenye 0 pa kwenye particle p, yule phase difference must be expressed firstly. It must be expressed by the letter this letter here, as we observe, my lovely students, which might be equal to the x divided by lambda. Lambda imply the displacement, lakini huyu x ana imply the distance from 0 from O up to the point p, my dear students. Then we times it by the 2 pi. Finally, we could get that the phase angle must be equal to 2 pi x divided by the wavelength. Kwa huu ndo kanuni ambayo tutakuwa tunaitumia kuweza kutafuta the phase difference kwa kuchukua 2 pi alafu x we divide by the wavelength, my lovely students. So therefore equation number 10 can be written at this one. So instead of expressing the equation number 10 as y along to the coordinate x, t, which is equal to a sine w to a sine bracket wt minus this phase angle, we should express it by saying that this displacement along the coordinate point x, t might be equal to a sine bracket wt minus the 2 pi x divided by the wavelength. But we know that the value at the 2 pi over wavelength must be equal to the constant. Kwa tamwambia sasa kumbe y the displacement at the coordinate point x, t is equal to a sine bracket wt minus kx as we seen here, my lovely students. So this could express the equation number 11 for our topic number 8. Kwa hiyo atakuwa ni equation wetu wa 11 kwenye topic yetu number 8, as we have been told, my lovely students. So in equation this one, in equation number 11, we should say that k must be equal to 2 pi divided by the wavelength, as I told you, my lovely students. This is not a new concept for you. So this is known the wave number. Kwa hiyo itakuwa itaitwa sasa ni wave number. The k is called the wave number, which is expressed as 2 pi divided by the wavelength, my dear students. If the wave moves from right to left, imagine we have the waves, and those waves they try to move from right up to the left. Kama tuna waves zetu, zile waves na move kutoka upande wa kushoto, upande wa kulia kuelekea upande wa kushoto. Now the particle will read that at O by the face. Kwa hiyo the particle atasomeka ni particle P we read that at a 0 by the face angle, ambayo atakuwa ni vice pi, ambayo atakuwa ni psi, ambayo tulimuona pale anabini express it is own symbol. So the displacement y at point P is given as this one. Kwa ili tuweze kupata sasa displacement pale, kama particles ana move kutokea kulia kwenda kushoto, hapa kwenye formula yetu tutabadilisha, itakuwa ni positive. Lakini kama atakuwa na move yule particle kutoka the left side kuelekea the right side, hapa kungekuwepo na negative kama tulivyoona kwenye zile equation number 11 pamoja na equation number 10. Kwa sasa, kwa sababu particle yetu ana move kutoka kulia kuelekea kushoto, we should express the displacement along the coordinate point x, t might be equal to a sin bracket wt, then we add by the kx, ambapo huyu hapa k tunamuita ni wave number which is equal to 2 pi divided by the wavelength. So this will be our equation number 12. Kwa hizi ndio itakuwa ni equation yetu number 12, my dear students. So therefore, the displacement y of the particle moving from left to the right, wave vice versa can be written at this way. Kwa sometime ukiwa na particle sasa zina move, zinaenda kulia, zinarudi kushoto, zinaenda kulia, zinarudi kushoto, wavelength ya displacement yake, my dear student, itakuwa ni sawasawa na a sin bracket wt plus or minus wa kx, ikiwa inamaanisha kwamba anapokuwa anaenda kulia utapata equation mbili, anapokuwa anaenda kulia na anapokuwa anaenda kushoto. Kwa anapokuwa anaenda kulia itakuwa ni a sin bracket wt minus that kx, lakini anapokuwa anatoka kulia anaenda kushoto atakuwa ni a sin wt plus or minus kx. Kwa sasa overall we should say that if those particle they try to move at the left, from the left to right, then right to left, should be expressed as a sin bracket wt plus or minus this kx, and this will be the question number 13 for the topic number 8. So since y represent the displacement of the particle at the wave at travel, sasa tunajua kwanza kwamba huyu y ana express the displacement particle, the displacement of a particle at the wave at travel, then the particle velocity vp at any instant is given by this one. So sasa hapa ndo tunaweza tukapata formula ya ile displacement, ile velocity kwa kudifferentiate ile equation yetu. Kwa tutachukua hii equation tutaidifferentiate, mwisho wa siku tutapata kumbe vp velocity along to the point p might be equal to aw cos bracket wt plus or minus at the kx as we have been told here. In addition, since the displacement y remain a constant, kwa kama instead sasa tutamwambia kwamba kama huyu hapa ta remain a constant, basi wale particles watamove from each other. Kama huyu displacement y ata remain a constant, watamove each other as we have been told. Now we could say that p1 and p2 then the wave or the phase velocity which is rate at which the displacement or wave moves across the oscillator is given by this one. Kwa atabini expressed kama atakuwa na uwezo wa ku move at the constant displacement. Now v must be equal to dx divided by dt, ambayo ni sawa na plus or minus wk. Kwa watapokuwa ni the same, tutapata kumbe velocity must be equal to plus or minus the angular velocity divided by k, and this will be the equation number 15. 5, my lovely students. So by saying that, we should conclude by we should keep it our mind that equation number 13 and also the equation number 14 and also 15 apply for both a transverse and also the longitudinal or progressive waves. Kwa hizo zote zinakuwa zinatumika eza kwenye transverse pamoja na kwenye ile longitudinal progressive waves. So by saying that, this is the end of our discussion, my lovely student. Now I wish you all the best. Have a nice moment.